If you have spent any time on the customers floor, you know that your campaign life is only as good as your product distribution. Precision at the stock line is not just a goal, it is the heartbeat of the fund stability. So today we are deep diving into a DANCU gearbox, a design that has fundamentally defined mechanical robustness for the next generation iron making. By end of this session, you will walk away with three critical deliverables. First, an understanding of how mechanical decoupling elements structural fatigue. Secondly is how hydraulic precision eradicate the drift that kills your charging matrix. And third, the real world ROI seen in massive fuel saving and productivity gains. So looking at the screen, you will see the intricate blueprint of DANCU units highlighted in a vibrant orange glow, signifying the leap from the legacy complexity to modern engineering. So this is not just a component upgrade, it's a strategic shift in how we manage the reactor stop. So, but before we get into the gears, we have to look at why legacy system are failing our modern production target. So, coming to our next slide, which is basically on ultra large furnace demand for zero burden distribution. So in the post 2020 era of high efficiency decarbonization iron making, we can no longer afford for burden distribution to be bottleneck. So look at the left side of this visual, that messy black and white sketch represent a legacy top charging empirical, overly complex and frankly prone to mechanical fatigue. Now shift your eyes to the right, where the DANCU gearbox is shown as a streamlined, growing orange schematic of permanent stability and its stability to also. So as we push the higher PCI rates and lower carbon footprint, our equilibrium must minimizes moving parts and eliminate historical failure point. So if your gearbox fails, your gas flow distribution becomes a chaotic variable that spike your fuel rate and degrade your refractory. So we have developed this architecture to ensure that your campaign reliability is never compromised by a mechanical breakdown at the throat. We are moving away from good enough towards permanent stability. So the secret to this stability lies in how we handle the complex movement of the distribution chute. So coming to the decoupling complexity, about the this is about the separation of rotation and tilting. So in traditional gearbox, the rotation and the tilting devices are intervened, so creating a nightmare of interlinked mechanical stress. On the slide, follow the white arrow between the two main components. The top gray unit houses the rotational motor, while the bottom orange highlighted unit contains the hydraulic tilting cylinder. So by completely decoupling this movement, we isolate the forces. This design fundamentally eliminates the primary failure points of legacy system because the drives no flight is other for the mechanical priority. So from an operational standpoint, fewer moving parts might significantly um, less downtime and much simpler spare part inventory. So when you decouple the complexity, you gain predictable performance. So this separation is the foundation upon which we build the rest of the system structural integrity, allowing us to focus on physics of the load itself. So this leads us directly to how we manage the physical forces acting on the main bearing. So coming to our next slide, which is about to eliminate the load inversion at the core. So this is where the physics gets interesting. So follow the red arrow on the left diagram level legacy vulnerability. So in older design, when the chute reached a certain position, the center of the gravity would shift outside the bearing diameter, causing a destructive load inversion. So this create a praying force that tears apart your seals and bearing. Now look at the DANCU stability diagram on the right. Notice the uh, uh, notice the orange dot. The center of gravity is perfectly centered. So V is the main bearing with a maximized seat diameter, so that regardless of where the chute is tilting or rotating, the load is always contained within the bearing footprint. So the white arrow pointing strategic down represent continuous structural stability. So for you, this means an end of structural fatigue and those surprises bearing failure that have always seem to happen in middle of a record breaking production run. So, but mechanical stability is only half the battle. So, we all also need absolute precision in where that material lands. So, coming to our hydraulic precision. So, eradicating tilting angle drift. If you cannot trust your tilt angle, you cannot trust your gas utilization rate. So, these slide illustrate our tilting range precisely calibrated between 10 to 63 degree. In legacy system, mechanical link would veer down, leading to tilt angle drift, the silent killer of your charging matrix. So we have replaced those sloppy mechanical linkages with a high precision hydraulic cylinder. These ensure absolute repeatability. When you call for 42 degree, you get exactly 42 degree every single time. The life of the campaign. So here is the hues. By eradicating drift, you maintain a consistent gas flow distribution which directly prevent uh, wall working and reduce the risk of step burn through. So precision is the difference between a furnace and that runs uh, and a furnace that perform. So let's put these two philosophies side by side to see the clear evolution of the technology. So, as far the slide is 6 is concerned about the anatomy of a modern gearbox, and if you look into, let's summarize the technical jump we have just discussed using this comparison table. So, on the left you have the legacy design, intervene drives prone to the inversion and susceptible to that um, dreaded tilt angle drift. On the right, highlighted in that bold orange box, is DANCU standard. So we have distinct separated drives, say center of gravity, say unit permeability within the bearing, and hydraulic cylinder that provide zero drift over time. So from a for a foreman or a manager perspective, this table represents the move from reactive maintenance to proactive reliability. So you are not just buying a gearbox, you are buying the integrity of your position data. So when you position integrity is guaranteed, your metallurgical modes actually start to match your real world furnace output. So it is about creating a predictable environment inside a very unpredictable reactor. So of course all this technology has a actually fit on your furnace top. So which brings us to spatial efficiency. So maximum performance, minimum footprint. We know that the headroom is often at a premium, especially during a retrofit. So look at the top section. We have optimized the gearbox body to save 800 millimeters, but the real game changer is the proprietary combination valve shown in the lower orange section, which integrate the material gate and the seal to save another 900 millimeters. That is the total system logic. Mm, with its all other dimension. So, so you can see that total system height reduction of up to 1700 millimeter, and this means the DANCU unit requires minimal modification to your existing skip bridge to our top structure. So you get a modern high tech charging system without massive capex on rebuilding your entire top tower. So it is the ideal solution for older plants looking for the step into the future of iron making without a total tear down. And once it's installed, we have made sure that keeping it running is easier than ever before. So frictionless maintenance by design is our next upcoming slide in this presentation. So as you can see, this maintenance should not be a struggle. We have simplicity and automation. So first the manual icon, chute removal and the reattachable are performed uh, safely from outside the furnace via the distributor manhole. Second, the lock icon. We have replaced damage prone mechanical with robust simple mechanical lock enabled by hydraulic power. So third, look at the automated lubrication icon with Wi-Fi style system. Mm, so this system uses position sensor to guarantee the exact volume of grease reached every bearing. So by connecting directly to your central supply, we eliminate manual cartridge replacement entirely. So this reduces your OPEX and more importantly keep your people away from the it is away from the hazard of the furnace top. So we have engineered the friction out of your maintenance schedule. So now all these engineered second which sounds great on the paper, but let's look at the actual data from the field. So our next is about Japrostil blast furnace number 3. So number speak of themselves. So at Japrostil blast furnace number 3, the implementation of the DANCU system delivered a massive 5% reduction in the coke rate. So we also saw a 10% increase in total productivity. Most importantly, for modern operation, the system seamlessly supported a 10% increase in PCI rate. So when you maintain total mechanical integrity, will you can afford to aggressive with your fuel optimization? So you are not playing it safe because you are worried about the gearbox. You are pushing the limit of the furnace because you trust the equipment. So this is the so what of DANCU it burns you, aging or charging system into a driver of profitability rather than a limiting factor of your operation. So to wrap things up, let's look at the ultimate goal of these technical innovation. So we can say the standard for mechanical robustness. So in conclusion, the DANCU gearbox is not just about gearbox and cylinder, it's about the uninterrupted campaign life. So follow that arrow, mechanical simplicity, hydraulic precision and spatial efficiency all feed into one goal, profitability. So by eliminating failure points and optimizing the footprint, we have proceeded the ultimate mechanical foundation for high efficiency iron making. So burden distribution should be a lever you pull to increase your margin. So never a bottleneck that holds you back. You have devoted a lot of time for this, and I hope this gives you a clearer picture on how modern technical presentation is paving the way for the next generation of blast furnace performance. So let's build a more reliable future and one charge at a one time.